for us in this unit. So the nice thing, the one thing I'm going to tell you, nothing new today. As soon as I start solving, you're going to be okay. Okay, trig again, sine law, cosine law. Okay, like I'm telling you, it's not going to be new, but you just need to know what do you do when you get presented with something like this. Okay, so page 57, calculating sides of polygons. Here we go. Okay, so calculate the value of the indicated side or angle. Determine the value of side x. So we want this side right here. You should realize that if this is 37, right, we could assume that this is 37 as well, right? If this is 37, then this is 37 as well. This only works with regular polygons. We cannot do this unless it's a regular polygon. Okay? Can we use trig right now? Not yet. We need at least an angle, right? Wouldn't you agree? Is there a way we can possibly find this angle here? It's called the central angle, right? Duh, right? Central angle, right? So let's figure that out first. That'd be 360 divided by n, right? That is 360 divided by, let's count. Check mark on the first one you count. Please don't get this wrong, right? So 1, 2, 3, 4, 5, 6, 7. 7 sides, right? So let's put that somewhere over here. N is equal to 7. Very important. I counted that. So we're going to divide this by 7. So 360 divided by 7. Yeah, that is okay. If it's a decimal, 51.43. 51.43 degrees. Okay. So now we have that one angle we need, and that's an SAS, right? You see? So we're going to just draw that out here real quick. This is X, this is 37, 37, 51.43. So basically the central angle is your starting point here. Central. What kind of triangle are we looking at there? It's an isosceles for sure. Cannot be equilateral because then it would need to be 60 here, right? So it's an isosceles. So let's start solving for it. So for A, I'm doing A here, right? X. Some of you are still using SOHCAHTOA from grade 11 or grade 10. You cannot really use that unless it's a right triangle. So maybe just refrain from using it and just stick with sine law, cosine law. That's why I don't review basic trig. We call that primary trig. Maybe don't use it, okay? So 37 squared plus 37 squared minus 2 times 37, lots of 37s, eh? Cosine of 51.43. I could give you a 99-sided polygon, right? And you should be able to do the same thing. That'd be pretty brutal, right? To count the sides, it would almost look like a circle, right? I won't do that, but I'm just saying, right? So you do that. If you have a good calculator, you just type the whole thing in, and you got 1030.938, and that keeps going. So cosine law is always our friend. We do the root. We take the root of that. That's 3211. 32.11 centimeters. And by the way, every single side along this, outside this polygon, is 3211, right? Like it's no surprise there. So for B, once you've written this down, B is asking for the perimeter. Right? Perimeter, I hope you know by now that it's the distance along that shape, right? If you were to travel along the outside, right? So basically the perimeter would be 7 sides in this case, times 3211, and you can use the rounded answer because we have this in part A, B kind of split up. So 3211 times 7, so that is 224.77, and we are in centimeters. It's not centimeters squared, right? Because it's just the distance around. It's not area or volume, okay? So that's our answer. What's this polygon called? Anybody brave enough? 7-sided? Remember that table I gave you? If you watch the video, you know what I'm talking about. I'll show you though, because it's so if you go to page 53, right, triangle, the prefixes kind of give you the number of sides. Quadrilateral, penta, hexa, hepta is 7, right? So I go all the way to deca, which is 10, and dodeca is 12. And there, I don't have one for 11, but I would expect you to know all the way up to there. Not very common that you need to remember that, but if it does, you should know, right? N is equal to 7 sides, right? This is a heptagon, right? Heptagon. Okay. The area I will not do. I don't expect you to know how to find the area of that thing. But if you like a challenge, I will give you the answer. Just write this down. Might be a good bonus question. And the way I do it is I split it up into triangles, obviously, and I find the area of just one triangle, and then times it times 7 in this case. So you need to find the height of it. You need to do a lot of work to get it, but this is the answer. If you're interested, if you want to give it a try, you go for it, okay? I wouldn't expect you to do that unless it's a bonus, right? Okay, why don't you practice this right away? So we're gonna go to not 58, we're gonna skip 58 for now, and just go to page 59. There are 2 questions there. Try at least one of them. Would you be able to do that based on what we just did? Would you be able to do that? And I'll give you the answers. For the first one, if you don't want to look, just don't look up for now. But this should be a nice and easy, like if you know what you're doing, you should be able to get that. For now I'm going to leave 59, like I'm not actually going to go over it because I just gave you examples. The perimeter for this one, if you want to have the answer, would be 80.30 inches because you multiply this by 10, right? And for the second, the perimeter is 151.91 feet. Right? So you have those answers there if you want to give that a try. Okay, let's go to 58. It's a little different. Maybe I'll put a note here, right? Outside length provided, right? This is a case where I give you the outside. Now I'm curious to see, can you figure out basically, on a circle be the radius, right? But it's from here to the center. For every interior angle to the center, it's the same distance if you do this right. Okay. So let's explore this one. I'm just going to focus for now, like I know that there's a cross line right here, but I'm just going to focus on this one right here. Okay. That triangle there. Let's count how many sides. 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon, right? Central angle would be 360 divided by 8, just like before. Okay? And that's 45 degrees. Make sure you write that down. This would be step number 1, and this would be my second step. So now I know that this 45 in here, okay, this is 45 degrees. I also know that this side is the same as this side, correct? It's an isosceles triangle. So let's bring that out, okay? So for A, we're just going to bring that out, make it a little bit bigger. We know that this is 180. We know that this side is the same as that side. And we now know that this is 45 degrees. Do you see the pair? Okay, we're going to have a pair there. So that is key for sine law, right? What do we know about these two angles here? This side, right, is equal to this side. So we actually know that these two angles will be exactly the same. Let's call this A and B. Oh no, B is already being used. It's going to go C like that. Okay. Angle A is the exact same as angle C, which is 180 minus 45. Right? You take the 45 away, you divide that by 2. So that's 135 divided by 2. It gives you 67.5 degrees. This is step number 3, by the way. Right? I figured out the number of sides. I figured out the central angle. Then I brought that central angle with me, and I used it to, right? I take this away from 180 and split it in half because it's the same. So put 67. This is x here, and the 67.5 can go here. 67.5, 67.5. So these two sides are exactly the same. So let's just solve for x right here. So we're going to go sine of 45 degrees over 180, and then we'll go sine of 67.5 over x. So this one is a bit more work, right? This one. So x would be 180, right? These two multiply. 180 times sine of 67.5 divided by sine of 45. That's 235.18 meters. That's right. This is all the work we did for A. And I'm going to introduce some highlighting here, right? This number entered there, okay? So that it sticks out. It's like, what did I do? How did I come up with that? And this pink one here, right? Make sure you highlight that, right? The 45 shows up here, but it followed me here, right? It's easier to see when you go through it. I don't know, I don't want to do the pair thing, right? But you do have this pair, and so you found x. This is all A here. I'm going to actually just box this all in. This is all for question A. For B, let's do some reasoning here. The length of side AB. So the question is asking, what's this length here? We know that one section is 235.18. So this section right here will be 235.18 as well. You see that? Okay, you should see it. It's almost like the radius on a circle, right? So I will just say AB is equal to 2 times 235.18. .36 meters across. Okay. The perimeter, duh, right? It'll just be 8 times the 180. That's 1440 meters. No problem there. What's this polygon called? 8-sided octagon, right? Octagon. I used to say oct, right? Octopus and stuff, and then a student says, so I said 8 like octopus and stuff, or 8 like October, right? It's the 8th month of the year. I'm like, no, it's not. So it's not always the case, right? Calculate the area of this polygon. That's a challenge. I don't have the answer. You give it a go, and if you want me to check, I might have that answer for you by tomorrow. You know what? For homework, if you want to try this, I would just say 59 to 61. Okay? Homework 59 to 61. I will post that and basically just review your skills on that. I will probably have one of these cases tomorrow on the AC, if not both. But for sure, the cosine law, make sure you know that one.